So I bet you thought that was a cat. What didn't you? Well, actually, that was Mr. Pouch. All right. Well, anyway, we are in section 6.2, continuing with our study of solving systems of equations, and more focused on the substitution method. So our goal is staying the same as we had last time, solving systems of equations using substitution. And just to recap, the substitution method, it just requires a lot of substituting in. So going back to those Glade plug it in, plug it in. We're plugging in things for a lot of things. So here's the basic steps, and we can put these back on in our examples today. So first, make sure one of the equations is solved for either x or y. If it's not, then you're going to have to do something with it, or maybe this isn't the best method. Then solve for the remaining variable. Or sorry, substitute that expression in for the other equation, and then solve for the variable that's left. And then finally plug that number in for either of the original equations to solve for the other variable. And here we'll take these directions right here, and we'll bring those over with us again. And what we're going to do is a couple special situations here. So I'm going to give you two examples. And these are going to be infinitely many or no solutions. So you may remember from back when, hold on one second. For some reason, this isn't working. All right. Back when we were originally solving equations, and we would end up getting like a number equal to a number, and the variables were gone. That means that there was, depending on if it was true or not, it was either an identity, which means infinite solutions, or there was no solution. So we're going to get similar things here, kind of like when we were graphing as well. So let's solve these two equations using substitution and see what happens when we have a unique situation. So first of all, let's make sure, let's do letter A. Let's make sure one of the equations is solved for either x or y. So we're doing A right here. All right. And looks like our first one is solved for x. That's good. So step one is done. Now substitute the expression in for the variable in the other equation. So I'm going to substitute this expression, because x is equal to that, and put it in for x in the other one. So that's what x is. It says x is negative 2y plus 4. So instead of x right here, we're going to do 3.5 times negative 2y plus 4 plus 7y equals 14. So everything else is staying the same. We're just replacing the x with what we're told x is equal to. All right, now we're going to simplify and solve for y. So you got to remember the steps for solving equations. So first, if there's parentheses, we got to get rid of those parentheses, and we're going to do this distributive property. So when we distribute, 3.5 times negative 2 is negative 7, I believe. So we have negative 7y. 3.5 times 4 then would be 14. So plus 14. And then we have plus 7y equals 14. So we substituted in. We're in the process of solving for y now. So remember, if there's variable terms on the same side, here's our divider, variable terms on the same side, we can combine them. We have a minus 7y and a plus 7y. And you know what that makes? 0y. Those are gone. So we just have 14 left over here. And that's equal to 14. Now, there's no variable left, so we can't even find a y value. That means we can't find an x value either. But 14 equals 14 is a true statement. And you may recall that means it's an identity or infinite. There are infinite, I spelled it wrong already. There are infinite solutions. All right. That's how you do it. We solved for it, and we don't need to plug anything else in and check, because there's no way to do that. All right. So what I'm going to do with this is I'm going to minimize this, and we're going to do the second one, see what happens with the second one. All right. So we'll slide this over here. Let's do letter B now in the blue. So first of all, make sure one of the equations is solved for either x or y. And it looks like we have the first one is solved for y. Excellent. Check. Done. Second one, substitute the expression in for the variable in the other equation. So we're going to substitute this 3, because y says it's equal to 3x minus 11. So I'm going to plug that in for the y there. So instead of y, we're going to say 3x minus 11 minus 3x equals negative 13. Done with step 2, we substituted in. So now we're going to try and solve for the remaining variable, and there's only an x. So on the left side, like last time, we have two terms that we can combine, this positive 3x and this minus 3x. Change it to a plus and negative, so we know it's a negative 3x. What happens there? Cancels out again. So those x's are gone. There are no x's left, and we're just left with a negative 11 equal to a negative 13. Not true. So that means there is no solution to this one, because we can't even finish the rest of these steps again. We did this. We can't do this anymore. So there's no solution to that one. So those are the two unique situations, or how we find the two unique situations when solving systems of equations using substitution. All right? So review how we did substitution. These are the two unique situations. Otherwise, the only other situation is if you can solve for both x and y. You get an ordered pair again. So that is systems of linear equations. Again, take a look at this one. I mentioned it on the last video, but this one word problem where you can create the two equations and solve the system. So remember the goal. Go back to the goal and think about what you know about solving systems of equations using substitution. We'll see you next time.